Hello, and welcome to another Digital Differential Equations lecture video for Salt Lake Community College. In this video, I would like to continue to explore numerical solutions to differential equations. In our last video, we were looking at how to use Eulers' method to approximate the solution to the initial value problem y prime is equal to y plus 1. Starting with y of 0 is equal to 1 and a step size of 0.5. And I mentioned that in practice, nobody uses hand calculations when approximating solutions to differential equations using numerical methods. That in reality, we would like to use the power of Microsoft Excel or some other solver to be able to increase our efficiency. So to do so, I'd like to show you a template that I've created in Microsoft Excel. And I'd like to be able to recreate this template with you. In general, what you should notice on our template is the differential equation, or the initial value problem that we're solving, the exact solution when available, a space to give the specifications for our numerical method. So tell me what the step size is you're going to be using. Tell me what the initial conditions are. You should tell me what does Eulers' method look like for the differential equation that we are solving, and what does the exact solution look like. You'll notice a table I will create that will show me which iteration we're on, the time stamp that we're on, what Eulers' method gives as a solution, what the exact method gives me as a solution, and I'm also going to look at the error between the Eulers' method and the exact solution. And then finally, I'd like you to be able to produce a graphic that visualizes the numerical approximation. But again, I'd like to do all this with you, so let's clear our table out so we can do these together. Maybe a nice place to start would be here. Well, actually, I'd like to go one more step back. A lot of students ask me how I enter my equations into Microsoft Excel. And I'm not going to do all of them with you because that takes a little bit of time, but I'd like to do one of these with you. So let's get rid of this cell that has Eulers' method. Okay. So the way I get my equations in Microsoft Excel is I just start typing them in. For example, Eulers' method, we said from our previous video, was going to equal to y. But I had a subscript in here. It was y sub n plus 1. And I could enter my subscripts up here under the font menu in Excel. So if you click this little arrow down here, you can choose subscript. So here we're going to have y of n plus 1. And I don't want the rest of what I write to be in subscripts, so I'm going to turn the subscript feature off. So y of n plus 1 is going to equal to y, and we had it as y sub n. Now, it's kind of a nuisance. You have to turn the subscripts on or off each time. But it was y sub n plus h times, in Microsoft Excel, you're going to notice that the times symbol is required, times, it was y sub n again, plus 1. And so you'll have to duplicate that for entering in your exact solution with sub or superscripts as appropriate. So this would be where I would like you to be able to start when creating your template. Now, the first thing I'd like you to do is to be able to put in your initial conditions. And the nice way to putting in initial conditions in Excel is to use a formula. Now, our initial condition is t of 0 is 0 and t and y naught is 1. But I need to put them in my table. And I'd like to make my table smart. So to do that, I'd like to enter things in as equations. So let's start by entering the equals sign. And our initial t value is going to be t naught. It's here. It's in cell C6. Cell C6. So it'd be column C, row 6. And I'm going to hit enter. Now the reason I'm doing it this way is because if I decide to change my initial conditions later, let's say I started at time 3, it'll automatically change the table that I'm creating. Let's put it back at 0 for now though. Now for Euler's method, we're still going to have the same initial conditions, so it'll be referencing my initial y value though, which would be y of 1. And notice that's in cell C7, column C, row 7. So I want that to be the same. Now let's start filling in our table. First, let's put in our iteration that we're on. And we're going to start with our 0th iteration, when n is 0. Or our first iteration, but it'll be when n is 0. And then we'll do 1, 2, 3, 4, and so on. Now I could continue to type in these values, but Microsoft Excel has the ability to recognize patterns. And so I'd like to use that to autofill the rest of this table. And so the way I do it is I select the first cell I want to work on, and then I hold down the left cursor and select maybe a couple of cells, enough that Microsoft will recognize the pattern. You'll then take your cursor, move it to the lower right-hand corner till your plus sign turns black. Then left click and hold it down, and let's go down till we get to 9 iterations. Okay. Now for each of these iterations, like we did in our hand calculations, I'd like to compute the appropriate t value. And so we started with this initial t value of 0, but remember we're taking step sizes as of a half. So our next t value is going to be, well, it's going to be a half, but I want to use Excel and write this as an equation. So I'm going to type in equals. It's going to be your previous cell, your previous time, which was in C10, and then we're going to add to that our step size. And our step size we saved in cell C5. So if you hit enter, it'll give you, when you use n equals 0, you're actually going to be calculating the value at t equals a half. Now, I'd like to use Microsoft Excel to auto-populate this entire column, but one more thing I have to change in here is the cell C5, my step size. I want this cell to be locked, not to change as I auto-populate. And one of the things you have to do that is put in a $sign between the C and the 5. And what this does is it makes your reference cell C5, the step size, be locked so that it never changes. And hit enter. Now to auto-populate the rest of this column, again, take your cursor, move it to the lower right-hand corner till you get the black plus sign. Left click and hold your cursor down and drag it down to the bottom of our table. This will auto-populate the entire t column. And notice it does increase your each t value by a half, because that's your step size. If you're curious how it's calculating any of these values, like maybe the 2.5, notice it's taking my cell C14, which was the time 2, that's column C, row 14, and adding to that our step size of C5. That was in cell C5. Similarly, if you want to see how Microsoft is calculating this cell that has the time 4.5, is taking the value that was in C18, so column C, row 18, which was 4, and adding your step size that was in C5. That's how it calculates the 4.5. Okay. Now let's look at Eulers' method. And I want to duplicate the hand calculations that we've done. Now we know Eulers' methods must agree with our initial conditions. That's fine. So the first one we're going to calculate is what happens when n is 0. And notice that when n is 0 in our Eulers' method, when n is 0, we're actually calculating y1. So let's go ahead and enter this in. Now I want to do this as an equation. So let's type in equals. Now when n is 0, we're calculating y1, and when n is 0, we have y sub 0 here. And y sub 0 was our initial value. That's in cell D10, column D, row 10. We'll add to this our step size, H, which was in cell C5. Again, I want that to be locked, so we'll put a $sign in there. Times, now in Excel you have to be explicit with your multiplication, so put a times symbol in there. Parenthesis. It's going to be y sub 0, so our initial condition, plus 1, parenthesis. And so notice if I hit enter, it will give me the initial y value that we calculated that corresponded to t equals 0.5. And what I think you should recognize is that this should confirm our hand calculations. When n was 0, we ended up getting a first t value of 0.5 and a y value of 2. I want to go back to our hand calculation template that we used. And so what I'm asking you to verify is that we just calculated this ordered pair. And we did this when n was equal to 0. Okay. Now I'd like to auto-populate the rest of Eulers' method approximations. And the great thing is since we use Excel and entered this in as a formula, I can use Excel to auto-populate the rest of this. And the way I do it is I click on that cell that has my formula, and I hold the cursor in that lower right-hand corner of the cell till I get the black plus sign. Then left click, hold that button down, drag it down to the end of our table. You should notice it's also confirming the first 3 calculations that we did here in our hand calculations. So 2, 3.5, 5.75. It's confirming this calculation and this calculation that we did by hand. Okay, so these are all the values that Eulers' method would use to approximate the solutions of this differential equation. Let us now add in our exact solutions. And we found our exact solution by hand already, so I want to use that to find my values in my table. And I want to do this again as an equation. So let's type in equals. And I'm going to type in my exact solution. It's going to be 2 times this exponent. And in Excel, to get an exponent in, you're going to type in exp of t. And then it's going to be, oh, but I don't want to put in t. I want to reference the time I'm using, which is cell C10. This is going to be my initial condition at time 0. Minus 1. So here I'm typing in my equation for the exact solution, but instead of writing t, we're putting in the t column, or my t value that's in cell C10. Now when I hit enter, this should give me my initial y value of 1. So it does match the initial conditions that we were given in the problem. That y of 0 has to be 1. But we did it using an equation or a formula in Excel. Now I'd like to use the fact that I entered this as an equation to auto-populate the rest of this column. So again, once you enter things in as an equation, as a formula, take your cursor, drag it or hold it over the lower right-hand corner till you get the black plus sign. Left click and then drag that down to the bottom of your table. Now I didn't want this to be all in red, so I'm going to unbold that and turn the red off. Okay. Now you should observe that these values agree with the ones that we did in our hand calculations. So notice that your exact value of 2.29, 4.43, 7.96 agree with the hand calculations, 2.29, 4.44, 7.96 that we did on our previous video. Okay. Now, I'd also like to be able to look at the error between Euler's method and our exact solution. Now, again, we're not going to be doing any error analysis in our class, as this is just our first look at numerical solutions to differential equations, but I would like you to just observe the error that we see. To calculate the error, I'm going to look at my exact value. So this value that was in cell E10 minus my Euler approximation value. That's in cell D10. Notice initially when we started, there's no error because this is what our initial conditions were. They both started at the same point. And now I'd like to auto-populate the rest of my Euler errors. So again, take your cursor, move it to the lower right-hand corner, hold down the left cursor, and drag to the bottom of your table. No, it shows me each error value. And I actually think I want to go the other way around. I think I want to change the order of how I did this. Because I'm noticing that my Euler approximation is below or less than my exact value. So I'd like these to be negative. So I'm going to change the order of how I did that. I'm actually going to type it in as equals Euler approximation minus the exact value. So D10 minus E10. Again, there's no error initially, but when we look at the rest of them, all my values are negative, indicating that my Euler value is below my exact solution. Okay. The last thing that I wanted to do that we had in our initial Excel spreadsheet was the graphic showing the Euler approximation to your exact solution. So to get Excel to create your graphic, you want to first select your data. And I'm going to select just the values that are in my first two columns. However, I think maybe Excel might actually do all three of them at one time. Let's see if I can do all three at one time. So I'm going to select all of my data. And I'm not sure if this will work. I hadn't practiced this doing it all at one time, but let's see if this does it. We'll select our data, and we're going to go up to Insert. When you click on the Insert tab, there are various chart options that become available to you. I'm going to click on the scatter plot chart icon. And I want to do a scatter plot where the lines are connected. You can do a scatter plot where the lines are, where it doesn't connect your dot with lines, but I want my dots connected with lines. So I'm going to go ahead and click on this option. And this automatically produces a graphic showing my various data. It's a little generic as it just says chart title, series 1, series 2. So I'd like to do some modifications to this table or to this graphic now. So let's start making it more specific. Let's change our title by double clicking in there. And maybe let's call this Eulers approximation to y prime equals y plus 1. Okay. Other things we could probably do is we can change our t-axis. Now currently it's just labeled 0, 1, 2, 3, 4, 5. But notice our t values went in increments of a half. So if you'd like to change this, you can left click on one of the values in your scale to select it, and then right click on one of those numbers to open up the Format Access option. And so on the right hand side, you can change your scale. Maybe we only need to go from 0 to 5. Maybe also we could change our tick marks. Rather than going in increments of 1, let's change them to be increments of a half. Okay, that looks nice. Maybe we could also change our legend. Rather than saying series 1 and series 2, the way I can change those is you can click on them and go down to where it says select data. And so let's change our data. Rather than calling it series 1 and series 2, let's select series 1 and hit edit. Now series 1, our first one was going to be, I think it's our Euler approximation. Ooh, it's a little unclear. Let me cancel. Let's see which one was which. So here I'm noticing the red series. That was our larger values, which is actually our exact solution. Had the larger values in it. So series 2 is our exact solution. And so that means series 1 would have been our Euler approximation. Okay, so let me right click on those again to format our legend. Nope, not format legend, to select data. And so let's let series 1, this was going to be our Euler approximation. Type OK. And series 2, let's edit that one. This was going to be our exact solution. And hit OK. So now our graphic has the appropriate legend to let us know which line is which. Okay, and now that we've completed the graphic, I think this completes everything I wanted to show you for using Microsoft Excel to create a numerical solution to a differential equation using Euler's method. Now I'm going to create a different video showing you how to create the modified Euler's method. But I'll see you in that video so that this video does not get too long. So I'll see you soon.